stories of information systems is this. We have seen what is the place for information systems in today's business context. Why is information systems required in modern business? We have seen that. We have seen what is the role information systems can play in transforming modern business. We have also seen what and hows of information systems. Summarizing the discussion till now, information systems, which comprises not only of software but also the hardware, services, people and procedure aspects, plays the central role in implementing the strategy of modern day business. Information systems are used not only at a day-to-day level business but also at the highest decision-making level. Information systems are implemented today in organizations in a hierarchical manner, each depending on each other. Such information systems basically help modern business organizations, one, directly to put forward their business goals and achieve them, indirectly by supporting the implementation of their goals and objectives. The ultimate result of using an information system in a business organization is to create this right balance between quality and pricing. All these ideas have been discussed here. While implementing these information systems, there are certain issues of human interest which come into picture. The questions of privacy, accessibility, the issues emerging related to the property rights. All these issues are also discussed. Once we are sensitive to all these human related issues and we are aware about all the implications and the positions of information systems, now the time has come to actually think on how to implement these information systems. Please meditate on the choice of words here. We are not saying building the information system. We are not saying developing the information system. We are saying implementing the information. The choice of word is well thought of. What we are doing here is not simply develop something in lab or an isolated situation, but actually trying to implement a workable solution in a real life situation. This problem is actually the heart of the crisis which is facing the information technology industry today. Let me take some time off before going into the actuals of the chapter to make you realize how serious this problem is. Most of you, I am sure, will not appreciate this, and it is natural. Unlike what most of you may actually think, the industry to which you are going to join in this year, of which I am a member for so many years, has not been able to develop enough tools which can make it qualified to call as a mature profession. issues are not new. These issues were plaguing us from 1960s. And people have tried to solve this problem from those times. Unfortunately, even as we talk today, these issues are not simple. What are those? Basically two. One, and the most primary problem plaguing this industry, lack of estimation tools and techniques. Second, complete absence of a mature process model. At the instance, you may feel that my arguments are wrong. Do we have enough estimation tools? Are there no enough techniques? What about all the models that you may have studied in the course of software? What about COCOMO? What about its very famous improvement model, the COCOMO 2? Believe me, they are not used anymore. They exist only in software engineering textbooks. They are only used in exam papers and nowhere else. Nowhere do people practically use COCOMO model to estimate. Estimation has two phases. Estimating the effort and estimating the cost. Effort again has two phases. Effort with respect to time and effort with respect to materials. None of these issues are clear in our view. Primary questions cannot be answered. Primary questions. The most fundamental question on which everything is grounded in any profession is estimation. When you want to build a house, the first question you ask is, how much will this cost? How much time will it take? When you are going for a surgical procedure, you ask the same question. How much time will it take to heal and what will be the cost involved? Answering these questions are primary for any profession. In engineering domain itself, certain areas have mastered this. For example, in civil engineering, estimation is a full-fledged discipline. If you go and ask, I have a 1460 site, I want a house which has 2 bedrooms and this site is specification. Any good engineer within a matter of time can tell you the exact cost involved and time taken. And most of the time, they will record it unless and until some unexpected thing happens. We can't find a parallel to this discussion here. These issues have been sidelined. They come only as fringe issues in software engineering. The teacher will casually mention that in the class that there are some basic cost estimation models and effort estimation models. These are the algorithms. If you know the algorithmic complexity, you can do this. This is hurting our profession like anything. And I keep seeing the shortcomings of our lapses when I am dealing with real world problems outside. Let me ask you a very straightforward question and you try to answer it very honestly. You are in 6th semester. in all practical terms, your engineering education will end here itself in 6th semester. 7th semester, we take it as an opportunity to introduce some emerging technologies to be introduced in the curriculum, and 8th semester is all about the full-fledged senior project. That means somehow by now, you should have acquired enough knowledge to practice the profession. If I ask a straightforward question, then after, okay, take 1 year, do you feel confident enough to practice the profession independently, not get a job somewhere and work on the basis of orders given? Practice the profession independently. That is, put up a board outside your house or put up a small office and say, so and so we offering consultancy services in this areas. Just like medicine professionals start up their own practice. Are you confident enough to start your own practice? Don't feel guilty. Because if you ask the same question to majority of the people who have passed out before 10 years also, they will answer the same. When I interact with some of my colleagues here and most of the colleagues outside, nobody feels confident. In fact, Government of India has come up with a very long plan for encouraging IT professionals and students to develop this consulting activities. It is very important for a profession to get the confidence of practicing independently. Unfortunately, in our area and in our area alone, there are no independent practitioners. Have you seen anywhere the board with the name saying this is an engineer and this is a consultancy he provides independently? In IT. Why have we come to this stage? We started giving engineering degrees in IT in India from 1989. Almost 20 years. Lakhs of students have come out. Lakhs of others from other disciplines have joined this stream. Still, if we can't cultivate this culture of independent practice of a profession, where do we stand? The problem is this, that we don't know to measure. If we can't measure, we can't estimate. The foundation on which independent practice stands is an ability to charge the people who come to you. On what basis do you charge? A doctor may claim a consulting fees of 150 rupees, 400 rupees, 500 rupees. How will an engineer charge his consulting fees? We don't know. But I practice it as a consultant. The basic lack of our ability to measure things has hurt us like anything. That we can't measure. See that? Whenever we define engineering, we say that it is soundly grounded on science and mathematics. Science and mathematics in turn are nothing but art of measurement. Now we are here, telling and confessing to ourselves that we can't measure. If the other day when I was seeing the functional and non-functional requirements written by you, I was telling to my colleagues also, it's a big letdown that students cannot write the requirements correctly. I will tell you something. You keep whatever you have written now, you keep it with you. Open it after 5 years. You will feel that the way you have written it now is the best you can do even then. Unfortunately, even the people who practice the profession for a long time cannot write the requirement statement correctly. See, ask a civil engineer or a mechanical engineer to write product specification document or PDS as they call it in mechanical engineering. The product design specification. Product design specification. You just go and see that document. At least one PDS document. Or, as I keep saying, see the blueprint of a building and all other plans. Combine together what kind of image you get about the building that has to be built. You take a building plan or the plumbing plans, the electrical plans and all those plans. The kind of integrity that is achieved, that is so enormous. Now compare that with the kind of documents that we produce. For example, class diagram, state chart diagram, sequence diagram. Can anybody claim that they can write such a perfect class diagram, sequence diagram, state chart diagram, that the moment somebody sees these three together, that is some static and some dynamic, they will get the image of the complete system? No. Why is that? Why is that we cannot be so true to our designs that we can communicate our ideas to others? Because we don't know how to quantify. See, for example, if a fan has to be designed, they will say the length of which should be this. The motor. Up to the smallest level, the screws which keeps the part together, everything can be defined perfectly. Perfectly it can be documented. We can't. Because we can't measure. Take as simple things as response time. I keep telling you, the system should respond within reasonable time. The system should be user friendly. We don't know. We don't know means that we can't put it down using proper quantifiable measurable terms means our profession cannot come under any legal review. You give a contract of building something. That builder is supposed to do the soil testing. After he does the soil testing, he knows what is the amount of foundation that has to go in. He should know what is the amount of traffic movement within the building, that is how many people will come and things like that. That will determine what should be this beam size, what should be its strength, what class of steel should he use. All that is made down to him. What will be the lifespan of the building? He will tell you all. He will study the climatic conditions of that place, study the wind movement of the place. He knows how to build such buildings which are resistant to those things. He will study the seismic graphs. He knows whether that place is under the belt of probable occurrence of earthquake, and he knows how to make the building strong against that. They have all these tools. There are building codes. There are environmental laws. He should abide to all these and then build it. Then if the building falls, you can take that person to court. Saying he has violated. Nothing of this sort can be done in our profession. Now this can be a cause for joy. Because whatever you do, you can't be able to report is a great thing. But if you ask me, that means that society has not accepted us still. We practice, as I keep saying, black magic. We practice black magic. That is, software works is actually a magic. That a website which shows all the result works without coming down is a great thing for which we cannot offer a reason. You may have writing in the software engineering books or your teacher may have told you, but I am telling you from my experience that software engineering projects are bound to fail. Every software engineering project, when it is started, is guaranteed to fail. That it becomes a success is an exception. Everything should fail. Software engineering projects never become successful. Nowhere. You take a very big software company or a small independent consultant like me, none of the software we write are finally labeled as successful. Either the users will not be happy, or the people who have commissioned the project will not be ready to pay us the kind of amount they have initially told us, because they don't think that the software we have given fit into the kind of expectations they had. Or at the end, the people who are supposed to use it will never use it. They will resist, saying that the software is not good. Whatever it is, software engineering projects fail. Fail to what level? An average software engineering project gets delayed more than 2 years from its estimated time. It is very common for a software engineering project to get delayed by 5 years, 6 years. If a software engineer says that this project will be completed in 1 year, take it for granted, it will not come in a proper shape at least for 3 years. It is common. And we have to live with that. So, the biggest skill a software engineer should have is to deal with these kind of issues. How will you convince your customer that you are actually doing something when he can't see anything? See, imagine yourself as a builder. The customer comes to your place, he sees foundation is being laid today. You can tell him, come after 1 week, I will get the walls erected. Come after some time. He can see the progress. How will you show the progress of software development? Can you show source code? Can you expect the customers to see the source code and say, yes, the development has happened? We have to live with that. These are the questions you will be asked to answer in this profession. Not whether you know Java or .NET or ASP.NET. Those are minor issues. The basic issue is this. So the problem of estimation, coupled with our inability to measure things, have today grown to such a level that if I have to accept very honestly, it is right time that we take one decision. What is it? Either all of us very honestly should say that sorry boss, whatever happened has happened, it was a mistake. Let us take out the tag of engineering from our programs. We don't qualify for this. Let us be outside of this domain for some time. Try and see whether we can build tools and deal with this problem on our own. And then come back into the fold of engineering. Or second, revise the entire professional practice to a dramatic level and introduce what the profession was looking somewhere in 1970s or period, the solid mathematical foundation. Software engineering, bring back all the mathematical foundations we once had. It is not that we did not have, we did have. But then it was all diluted. Either of these two decisions we have to take. I think there is a move. Slowly but steadily, people are realizing that we can't move like this. Do you think all the software companies which you may be planning to join actually don't face all these problems? You all get to hear only what media reports. That this company has bagged $4 billion contract from some MNC. You don't know what goes behind the scenes. Behind the scene, there is a lot of what I call as fish market scenes which will be enacted. It is literally fish market kind of bargaining because it is not based on solid data. See, if you want to build a building, you can give an estimate. This many materials are required. This much manpower is required. This material will cost this much today. Therefore, I am putting this much. You can say. For building a software,